Hello from Omoni Ayomide, your expert guide to jam chemistry success. I'm Omoni Ayomide, a dedicated chemistry teacher, and I'm excited to present the Jam Solution in Chemistry app. This is the app designed specifically to make chemistry easy for you. For just 1,000 Naira, you'll get access to everything you need to excel. In-depth video lessons. Let me break down each topic step by step, so you'll understand every detail and tackle any question with ease. Interactive ebook, packed with explanations and examples that cover the entire syllabus, making your learning journey smooth and straightforward. Jam-style practice questions. Test yourself with realistic exam questions, track your progress, and gain the confidence you need for the big day. With the Jam Solution in Chemistry app, I'm here to guide you all the way to success. This is your path to confidence, clarity, and achieving your jam goals. Ready to master jam chemistry with me, Omoni Ayomide? Download now for just 1,000 Naira, and let's get started on your journey to success. Sure, here's an in-depth explanation with examples of different aspects of a laboratory, including the equipment and safety rules. What is a laboratory? A laboratory is a designated space where scientific research, experiments, and analyses are conducted. It is specially designed with the right tools, equipment, and safety measures to ensure that experiments can be performed accurately and safely. Example, in a chemistry laboratory, students might perform experiments like titrations, where they measure precise volumes of acids and bases. The lab provides a controlled environment to ensure the reactions are safe and the measurements are accurate. Laboratory apparatus and their uses. 1. Evaporating dish. Material, typically made of porcelain for heat resistance. Use. This dish is used for the evaporation of liquids from solutions to leave behind solid residues, often after the solution has been heated. The broad, shallow shape allows increased surface area, which speeds up evaporation. 2. Beaker. Shape, a flat-bottomed cylindrical container. Use. Beakers are versatile pieces of equipment used for holding, mixing, and heating liquids. They can also be used for rough volume measurements, though not as precise as a graduated cylinder. Beakers often have a spout for easy pouring. 3. Aspirator bottle. Use. A bottle used to store distilled water or to aspirate, suck in liquids and gases in various laboratory processes. It typically has a connection for a rubber tubing that can be used to create a vacuum or suction. 4. Crucible. Material made from materials like porcelain or silica that can withstand extremely high temperatures. Use. A small, heavy container used for heating substances to very high temperatures. It is often used in the ignition or decomposition of materials, such as when heating salts or metals. 5. Woof's bottle. Shape. A glass bottle with 2 side tubes and a main central part. Use. It is primarily used to hold drying agents or to absorb unwanted gases during chemical reactions. It's particularly useful in situations where gases need to be purified or absorbed. 6. Conical flask or Erlenmeyer flask. Shape. A flat-bottomed flask with a conical body and narrow neck. Use. Often used in titration experiments for mixing solutions. The narrow neck helps to reduce spillage, and the wide base provides stability during heating. 7. Flat and round bottom flask. Shape. These flasks either have a flat or round base. Use. Primarily used for heating liquids in processes such as distillation. The round bottom flask is ideal for uniform heating, especially in distillation setups where it's heated over a flame. 8. Standard volumetric flask. This is a flask with an accurately known volume used for preparing standard solutions. The precise volume allows for accurate concentration measurements when dissolved solids are added. 9. Fume cupboard, fume hood. Use. A ventilated enclosure used for carrying out experiments involving hazardous chemicals or gases. The fume cupboard helps remove toxic or poisonous fumes from the experiment space. 10. Distillation flask. Shape. A round-bottomed flask. Use. This flask is used in the distillation process for separating mixtures based on different boiling points. It holds the liquid that will be heated and vaporized. 11. Bell jar. Shape. A large glass jar that can be sealed. Use. often used in experiments related to combustion. It can be used to create a controlled environment by sealing gases inside the jar for observation. 12. Gas jar shape. A cylindrical glass jar with a wide opening. Use. A gas jar is used to collect gases, typically over water displacement method, or dry gas. It's commonly used for the collection of gases in experiments like those involving chemical reactions. 13. Dropping bottle or pipette. Use. A dropping bottle is used to dispense liquids in small controlled drops. A pipette is similar but more accurate and is used for measuring and transferring small volumes of liquids with precision. 14. Spatula. Shape. A small, flat tool. Use. A spatula is used to transfer small amounts of solid chemicals or powders, often from a container to a weighing balance or other apparatus. 15. Burette. Shape. A long graduated tube with a tap at the bottom. Use. Used in titration experiments to dispense precise amounts of a liquid, such as a titrant, into a solution. It allows for very accurate volume measurements. 16. Retort stand with clamp. Use. A metal stand used to hold laboratory equipment such as flasks, burettes and condensers in place during experiments. The clamp can securely hold equipment at various angles and heights. 7. Desiccant. Use. A sealed container used to keep substances dry by absorbing moisture. It typically contains a drying agent like silica gel to maintain a dry environment for substances like chemicals or salts. 18. Measuring cylinder. Shape. A tall, narrow cylindrical container. Use. Used to measure the volume of liquids accurately. Graduations on the side of the cylinder allow for precise volume readings. 19. Kipps apparatus. Use. A piece of equipment used to generate gases in small quantities, typically for laboratory experiments. It allows for the intermittent release of gas, often used in generating gases like hydrogen or carbon dioxide. 20. Wire gauze. Shape. A flat mesh of wire. Use. Placed on a tripod or ring stand to support flasks and beakers during heating. The wire mesh distributes the heat evenly to prevent breakage of glass containers. 21. Filter funnel. Use. A funnel designed to hold filter paper for separating solid particles from liquids in a process known as filtration. 22. Condenser Liebig. Shape. A long tube inside a larger tube. Use. Used in distillation processes to cool vapors and turn them back into liquid. The inner tube carries the vapor while the outer tube circulates cool water to condense the vapor. 23. Centrifuge. Use. A machine that spins containers at high speeds to separate substances of different densities in liquids. It is used to separate fine particles such as cells from a solution. 24. Test tube. Shape. A small cylindrical tube with an open end. Used for holding and heating small amounts of substances. It is commonly used for qualitative analysis in chemistry. 25. Separating funnel. Shape. A pear-shaped glass funnel with a stopper and a tap at the bottom. Use. Used to separate two immiscible liquids, such as oil and water, by allowing the denser liquid to drain from the bottom, leaving the lighter liquid behind. Each of these pieces of equipment has a specialized function, helping chemists perform various experiments accurately and These are excellent laboratory safety rules. Let's break them down in more detail to ensure the safety and efficiency of all lab activities. 1. Dress appropriately. Lab coat protects your clothing and skin from spills or splashes of chemicals. It is also flame resistant, adding an extra layer of safety. Safety goggles. Always wear safety goggles to protect your eyes from harmful chemicals, flying debris, or intense light from experiments. Long hair can catch fire, get tangled in equipment, or fall into chemicals. Tying it back ensures that it does not interfere with your work. 2. Keep pathways clear. Proper storage. Store bags, books, and unnecessary materials in designated areas to prevent accidents. Cluttered workspaces can obstruct your movement and cause tripping hazards. 3. Do not taste or smell chemicals. Health risk. Chemicals can be toxic or irritative when inhaled or ingested. Never taste chemicals or try to smell them directly. If necessary, use a fume hood or waft the vapor toward your nose cautiously. 4. Do not attempt unauthorized experiments. Safety concerns. Only conduct experiments that have been approved by the teacher. Unauthorized experiments can be dangerous if they involve reactions that you are unprepared to handle. 5. Follow cautions in the lab exercise closely. Prevent accidents. Lab exercises often contain critical safety precautions. Read through and follow all instructions carefully to avoid dangerous situations. 6. Stay at your assigned station unless permitted to leave. Focus on your work. Moving around the lab can distract others or lead to accidents. Stay at your station unless you have a specific reason to leave, such as using shared equipment. 7. Avoid leaning or sitting on lab tables. Prevent contamination and accidents. Leaning on lab tables or sitting on them can introduce contaminants, disrupt ongoing experiments, or even cause equipment to break. 8. Horseplay is strictly prohibited. Safety first. Lab environments require focus and discipline. Running, joking around, or engaging in horseplay can distract you and others, leading to accidents. 9. No locations of fire extinguisher, eye wash station, first aid kit, and safety shower. Preparedness. Familiarize yourself with the location of emergency equipment in case of a fire, chemical spill, or injury. Quick access to these stations can prevent more serious consequences. 10. Report all accidents or equipment breakages to the instructor. Immediate action. If an accident occurs, report it to the teacher immediately. Prompt action can prevent further damage or harm. 11. Follow all teacher instructions carefully. Guidance and safety. Teachers provide specific instructions to guide experiments safely. Following their directions minimizes risks and ensures the experiment proceeds correctly. 12. No eating or drinking in the laboratory. Contamination risk. Chemicals or microbes can be transferred from the hands or surfaces to food or drink, leading to poisoning or other health issues. 13. Leave your workstation clean before leaving. Respect for others. Clean up your station to prevent accidents for others who may use the same workspace. Properly dispose of chemicals and wipe down surfaces to ensure the lab is left in safe condition. By adhering to these laboratory safety rules, you'll help ensure a safe and productive environment for everyone in the lab.